This video is part of Monopoly. In it, I will discuss the inefficiency of a monopoly as measured by deadweight loss. In Econ 101, you likely learned that perfect competition maximizes society's welfare. But how should we measure this welfare? One way to measure society's welfare is to equally weight the well-being of consumers and producers using a measure called total surplus. Total surplus is the sum of consumer surplus and producer surplus. At the competitive quantity, total surplus is as big as it can be. Producing the competitive quantity maximizes welfare. What this means is that at any other quantity, total welfare or total surplus is necessarily lower. Deadweight loss is what we call the net reduction in welfare or the loss in total surplus by one group that's not offset by a gain to another group. Deadweight loss is how much total surplus shrinks when a quantity other than the competitive quantity is produced. To better understand the concept of deadweight loss, let's look at a simple supply and demand model. Remember that demand represents the marginal benefit of a good. That is, at any quantity, the demand curve tells us what that additional unit is worth to the buyer, and so the maximum price the buyer would be willing to pay for it. Supply, on the other hand, represents marginal cost. That is, at any quantity, the height of the supply curve tells us the cost of producing that additional quantity, and so the minimum price the firm would need to charge to want to sell that quantity. Notice here that for Unit 1, Buyer 1 is willing to pay $50 because that unit is worth $50 to her, and Seller 1 needs to charge at least $20 to sell that unit because $20 is the cost to Seller 1 of producing that unit. That means there are lots of prices in between these two values that would be mutually beneficial. For example, if the price is, let's say, $35, then Buyer 1 is going to walk away with consumer surplus. Buyer 1 was willing to pay a price of $50, but if she only had to pay a price of $35, she would enjoy a consumer surplus of $15. $15 is how much more she would have been willing to pay on top of the $35 that she had to pay. At the same time, Seller 1 benefits from the exchange. Seller 1 required a payment of $20 to want to sell the good, but gets a payment of actually $35. This seller enjoys a producer surplus of $15. In other words, the seller receives $15 more than it needed to cover the variable cost of producing that good. By allowing this exchange, Buyer 1 enjoys consumer surplus, Seller 1 enjoys producer surplus, so society benefits from this additional total surplus. The same thing can be true when we see Units 2 and 3 being sold and bought as well. For Unit 2, the price Buyer 2 is willing and able to pay is more than the price Seller 2 requires to sell the good. Any price between these two values, so 45 and 25, would represent a win-win situation where Buyer 2 enjoys a consumer surplus by being able to pay less than he was willing to pay, and Seller 2 enjoys a producer surplus by charging more than it needed to charge. More specifically, if the price is $35, Buyer 2 would enjoy a consumer surplus of $45 minus $35 or $10. At the same time, Seller 2 is enjoying a producer surplus of $35 minus $25 or $10. Again, when this exchange of Unit 2 occurs, because both the buyer and the seller benefit, society benefits in total. By allowing Unit 2 to be sold and bought, total surplus increases. The same thing's true of Unit 3, because for the third unit, the buyer 3, is willing to pay a price, $40, that's more than the minimum price of $30 that seller 3 needed to charge to want to sell the good. Through this sale and purchase of Unit 3, total surplus therefore increases. Now, whenever the marginal benefit of a unit is bigger than the marginal cost of the unit, society's total surplus will increase through the exchange of this unit. At the point where marginal benefit and marginal cost are equal, there's no additional total surplus from that exchange. Total surplus ends up being maximized when marginal cost equals marginal benefit, or in other words, where supply equals demand. At any quantity other than this equilibrium quantity where supply equals demand, total surplus is necessarily smaller. For example, let's say that the market stops at a quantity of 2. Let's say that the quantity produced and bought is 2 units. This market is what we call inefficient because at a quantity of 2, we've got deadweight loss. The deadweight loss represents the surplus that could have been enjoyed had these transactions been allowed to happen. Deadweight loss is the area below the demand curve, under the marginal benefit, and above the supply curve, above the marginal cost, for all the units, not just the whole number of units, but all the units in between that could have been enjoyed had these transactions been allowed to happen. I like to think of the deadweight loss as written as the sum of the absolute value of the difference between marginal benefit and marginal cost added up between the units here, Unit 2, and Unit 4, or between the units that are currently produced and the units that would be competitive or efficient. What I like about this definition or formula of deadweight loss is it helps us remember that efficiency is where marginal benefit equals marginal cost. So inefficiency arises whenever these are not equal. Deadweight loss is measuring how unequal these are by summing up the extent to which marginal benefit and marginal cost differ on all the units that are not produced that would have been efficient. This also helps us remember the graphical depiction of deadweight loss, because deadweight loss is the area between marginal benefit or demand and marginal cost or supply, between the units that are produced and the units that would be efficient. So again, under the marginal benefit curve, above the marginal cost curve, from the units of 2 to the units of 4, 2 being what is currently produced and 4 being what would have been efficient. You might wonder why any firm would want to stop at a quantity of 2 when, for example, by selling the third unit, it could charge a price higher than the price it needed to charge, but still lower than the price consumers would be willing to pay. Well, let me explain that. Suppose what we're looking at is the demand curve faced by a monopolist and the marginal cost curve for the monopolist. Let's add to this graph the monopolist marginal revenue curve. Remember, marginal revenue has the same intercept as the demand, but is twice as steep. Let's say marginal revenue for the monopolist looks like this. This monopolist will choose to produce a quantity of 2 because that's the quantity at which marginal revenue equals marginal cost. At this quantity, the monopolist will set a price equal to 45. 45 is the monopoly's price, and 2 is the monopolist's quantity. Now, there is a buyer 3, who's willing to pay a $40 price, which would be higher than the $30 that the monopolist would incur by producing the third unit. But here's the catch. The only way to get buyer 3 to buy the good is to lower the price from $45 down to $40. And for a uniform or single price monopoly, you can't lower the price for buyer 3 without also lowering the price for buyers 2 and 1. Because you have to lower the price on all units to sell an additional unit, the marginal revenue from selling the third unit is lower than that price. And in fact, on the third unit, the marginal revenue is also lower than the marginal cost. A single firm or a monopolist would not want to sell unit 3 because in doing so, profit would go down. Again, because for unit 3, marginal revenue is less than marginal cost. The monopolist stops at quantity 2, even though had there been more than one seller, some seller would have been able to sell to buyer 3 at a price that allowed for total surplus to increase. Let's consider this example where the monopolist faces an inverse demand of P equals 24 minus Q, giving us a marginal revenue of 24 minus 2Q. The monopolist also has a marginal cost function equal to 2Q. As shown on the graph, the monopoly will produce the quantity at which marginal cost equals marginal revenue, which here would give us a quantity of 6. At this quantity, the highest price the monopoly can charge is the price that buyers would be willing to pay. Or at a quantity of 6, price is 24 minus 6, or 18. The competitive equilibrium is where marginal cost equals inverse demand. That quantity can be found by setting inverse demand, the equation for price, equal to marginal cost. Here we get a quantity of 8. Notice how the competitive quantity is bigger than the monopoly quantity. At the same time, the competitive price, here 16, is less than the monopoly price. Because the monopolist produces less than the competitive quantity, the monopolist results in a deadweight loss. The deadweight loss, again, is the area under demand, under marginal benefit, and above supply or above marginal cost, in between the units that are too few, the monopoly's too low quantity, and the higher competitive or efficient quantity. Here that gives us a triangle. To measure this deadweight loss, we're going to use the area of a triangle, which is 1/2 the base times the height. The height of this triangle spans from here to here. This value right here is the monopoly's price. Again, to find that, you set marginal revenue equal to marginal cost to get the monopoly's quantity, and then you plug that quantity back into demand to get the price. You also need for the height this value. This is the value of marginal revenue and the value of marginal cost at the monopoly's quantity. To find this number, plug the monopoly's quantity into either marginal cost or marginal revenue. For example, here the quantity is 6, so the value of marginal cost is 2 times 6, which is 12. Now we have what we need to form the height. Here the height of the triangle goes from 12 to 18, which is a height of 6. The base of the triangle spans from here to here. To find the base, we need these two quantities. We need the competitive quantity, where marginal cost equals inverse demand, and we need the monopoly quantity, where marginal cost equals marginal revenue. Here the base goes from 6 to 8, or a distance of 2. Now we have the information needed to calculate the deadweight loss, which is 1/2 of 2 times 6, which is an area of 6. This is measured in dollars. So what this means is that the monopolist produces too little and causes a loss in total surplus of $6.